everyone, and welcome back to Let's Talk Tech, brought to you by Sine Wave Technologies. In today's video, we're going to talk about CIDR notation. In our previous video, we learned about subnet mask and how they are used to identify the network and host portion of an IP address. We also learned that all IP addresses, both classful and classless, have a subnet mask, even if they do not have a subnet, and they're included together as a pair. CIDR, which stands for Classless Interdomain Routing, or sometimes referred to as prefix notation, is a set of Internet Protocol standards that are used to identify parts of the address to networks and devices. CIDR makes it easier to write an address's subnet mask. When we talked about subnet mask, we learned that in classful addressing, which is when an IP address follows the rules of its class, each class would have the same subnet mask. For example, all Class A addresses would have a subnet mask of 255.0.0.0. This tells us that the first octet is being used for the network portion, and the last three octets are for the host. Class B would be 255.255.0.0, and Class C would be 255.255.255.0. However, things get a bit tricky when you start to introduce subnetting. Subnetting is the practice of dividing classful networks into two or more smaller networks. This is where classless addressing comes into the picture because the addresses no longer follow their set rules. Subnetting uses bits from the host portion, lessening the amount of hosts and increasing the network portion. An example of a subnet mask for a classless address might look something like this. What CIDR does is eliminates having to write the subnet mask over and over again, and allows for a quicker and easier way to identify the different sections by writing it as a prefix and a suffix. The suffix is set apart from the prefix with a slash mark and identifies the amount of bits being used. For example, instead of having to write 255.255.255.0, you would just put /24, which represents the number of ones or bits being used. 255 means all the bits in that octet are being used, which is 8 ones, and there are 3 octets with 255, so 8 times 3 is 24. Let's break this down a bit more and check out a few examples. Let's say that we have a subnet mask that is 255.255.255.192. We already know that the first 3 octets equal 24, so how do we figure out the 192? By referring back to the 8-bit octet chart, we see that 192 is actually just a 1 under the 128 and the 64 because this adds up to 192, and then the rest are zeros. We are adding up all the ones, so 24 plus 2 would be 26, making this a /26. Now let's look at this the other way around, so you can see how this new standard tells us the different parts of the address. It's important to note that the ones present in a subnet mask are always in a consecutive line, then followed by zeros. With that in mind, let's look at this address and see what we can identify about it. Here, the 28 tells us there are 28 bits being used, which means that subnet mask would look like this. There are 28 consecutive ones, then followed by zeros for the remaining bits. This also tells us that it is a Class C because the first 3 octets are being used, and that 4 bits were borrowed from the host portion for the subnet. So how is this more efficient? Instead of having to write all this out in decimal notation or binary, by seeing the /28, we learned this address's class, its subnet mask, its subnet portion, and how many hosts are available in it. Well, that's all for today's video. If you've enjoyed this series so far and want to learn more about technology, make sure to like, subscribe, and hit that bell to be notified about our next video. If you have any further questions or just want to follow along to learn more tech, check out our social media linked below in the description, or take a look at our website at sinewavetech.com. I hope you all have a great weekend, and I will see you next week on Let's Talk Tech.